This is a production of Cornell University.
Okay, so we've been talking about the physical aspects of soil, but there's a chemical aspect of soil that we can test very easily. That is pH, which measures the acidity or alkalinity of any substance. And in soils, pH determines very much what nutrients are available to plants. So some plants can tolerate a wide range of pH, and some have a very narrow range of pH where they grow well in. So we need to know this in terms of plant selection. The pH test is very simple. We use the Cornell pH kit, which is a colorimetric test. And we'll try two different soils. There's two parts of the kit. One is the standard, and one is a wide range. We always start with the standard. So we have these cups where we're going to put a little bit of soil in one of the depressions. I'm not going to fill it up, just a little bit of soil. And then we're going to take one of the reagents here. There are two. We always start with bromthiamyl blue, which is the neutral range. We want to start with the neutral range, and then we can go up more alkaline or go down more acid. So using bromthiamyl blue, we're going to drop by drop. Until we have a little bit of free solution. We're going to mix this, oh yes, for about 10 or 20 seconds so that the reagent mixes with the soil. And then we're going to allow that solution to go down the channel. In this case, there's quite a bit of soil there, but I can still see a color. Well, what we're looking for is the color in the channel. So we use a color chart to determine what that pH is saying, is reading. And in this chart it says bromthiamyl blue on the top. So we're going to look at the color we find in the channel versus the color chart. I'd say somewhere between 6.0 and 6.2 based on the color of the chart, maybe 6.0. Okay, so if we're at one end of the color chart, we want to go further because we may not see exactly what the final pH would be. So in this case, we'll use another reagent in the kit, which goes from pH 5 to 6.2. It's at the lower end. So we take another bit of soil from our sample, put it in the other bowl, and using chlorophenol red, we're going to wet the sample. And mix it by tapping it so that the solution bathes the soil in the cup. Now we're going to allow that bead to go down the channel, back and forth. And we're going to use the color chart at the bottom, which says chlorophenol red, to see what our color is. You can see we're at the 6 to 6.2 range. So in fact, the 6.2, which we saw with bromthiamyl blue, is correct because we've corroborated that with another solution. So here it's 6.2, pretty close. So I'd say it's about 6 to 6.2 pH, and that would be the final determination for this soil. Now when we're changing soils and we're going to do another soil or another sample, we always want to clean our plate with deionized water, so we're not going to use the pH of the tap water to change our reading. So I have another soil here, which we're going to test. You can't tell anything about the soil by looking at it in terms of what the pH is, and that determines very importantly, how much certain elements are available to plant roots. So we're going to put a little bit of soil in the bowl. Start again with bromthymal blue, which is the neutral range. Drop, drop, drop. We have a little bit of free solution. Mixing it with the soil, and then getting a bead down the channel. And here, instead of that kind of yellowish green, we have almost a blue-green color, which would be at the end of the bromthymal blue chart, sort of 7.2. But again, we're at the end, we need to go further to see if that's the final range of pH. So here we take the wide range test kit, which goes higher with phenol red or much lower with brom creasel green. We're going to go higher with phenol red because we stopped at 7.2. We want to go up in terms of seeing what the real pH is. So here we're going to put some more soil in the second bowl. By the way, you want to have your hands clean when you do this, so you're not introducing anything into the sample. So here we're going to take phenol red, which is the high range, to see what this soil actually is. And we're going to mix it. Sometimes you see the color change when you're mixing it. And then we're going to get a bead down the channel. And what we're looking for is the film, the color film. And in this case, we used a color chart for phenol red, which is pretty bright. And here we're seeing we're not up at 7, we're more toward, I'd say, it's quite blue, so we're probably at 8.4 or 8.6. So we have much more alkaline soil here than we did in the first sample. And that's going to determine which plants can grow well in some of those types of soils. So we need to know that for plant selection. And it's a very simple test that you can do without any special equipment.
This has been a production of Cornell University, on the web at cornell.edu.